Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. This is the Math 8 edition, and I'm your host, Mr. Takeda, and I'm going to teach you some math right now. This is lesson 3.3 on angles of polygons, so if you're ready, let's go. So first of all, we start with vocabulary again, and our word today is polygon. A polygon is a closed plane figure, which means it's flat. It's a flat figure made up of three or more line segments that intersect only at their endpoint. So here's some example of polygons. You'll see that all the sides are straight lines because they're line segments, and they intersect at their endpoints. So they're talking about these corners or vertices, if you have. Not polygons. Why are these not polygons here? These have curved lines, and this one, it's not intersecting at just the endpoint, it's intersecting like at a midpoint. So not polygons. This is the big idea for the lesson, that the sum of the interior angles of a polygon with n sides is n minus 2 times 180. So let's pretend this is a triangle. The sum of the interior angle measures of a triangle we know is going to be 180, right? So n would be 3. 3 minus 2, we're going to follow order of operations. 3 minus 2 is 1. And so 180 is 180. Let's do it for a rectangle or any kind of quadrilateral, 4 sides. Well, 4 minus 2, this is the number of sides. 4 minus 2 is 2. 2 times 180 would be 360. All right, so that's how we're going to use that formula. So let's take a look at this example here. Find the sum of the interior angle measures of the school crossing sign. So this is a pentagon, 1, 2, 3, 4, 5. And so we do that again. The sum of the measures of these angles, 5 sides minus 2 times 180. So this is just kind of a continuation of what we did. 3 times 180, and I'm going to use the calculator for that. 3 times 180, 540. So 540 degrees. If I add up all these angles, 540 degrees. Okay. We're going to use that same idea to answer this question. In this question, we're finding an interior angle measure of a polygon. We're looking for this one. So they give us all these degrees here for all these different vertices here, but they left one blank, and we have to find the value of that. Okay, so what are we going to do here? Well, we have to find out how many sides there are, and then we can figure out what the total of this is supposed to be, the total of all these interior angles. So 1, 2, 3, 4, 5, 6, 7. There's 7 sides here. So S will equal 7 minus 2 times 180. So 5 times 180 is going to be equal to, in the calculator, 5 times 180, 900. Okay, now all of these will add up to 900. So I'm gonna start here and work my way counterclockwise. 140 plus 145 plus 115 plus 120 plus 130 plus 128 plus x equals 900. Okay, and then we're going to simplify all of these numbers. Let me put a line through here because these are two separate parts, right? This gets us that first question, the missing the unknown total, and now we can use that total. So I'm putting a line through there. Let's see. So I'm going to add all these up, and I get 778 plus x equals 900. I know I'm kind of like, let's see if I can bring this over here. Oops. Oh, sorry about that. I fixed it here. All right, so I got it a little more cleared over. So 778 plus x equals 900. All right, so now I'm going to subtract 778 from both sides. So x will equal 122. Okay, so the value of x is 122. Okay, let's see what's next. Okay, so here's a word problem, but it's in conjunction with another definition, and that definition is a regular polygon. A regular polygon means that all the sides are congruent and all the interior angles are congruent. They're all the same. So if they're all the same, that kind of makes our lives a little bit easier for us. Let's talk about this word problem here. A cloud system discovered on Saturn is the approximate shape of a regular hexagon. Okay, there's that word again, regular. Find the measure of each interior angle of the hexagon. Okay, so first of all, we need to find out what the total angles are in a hexagon. So that total angle would be 6 minus 2 times 180. So 4 times 180, and 4 times 180 is going to be 720. Okay, well, since they're all the same, then I can just take 720 and divide it by 6, since there are 6 angles here in that regular hexagon. So 720 divided by 6 equals 120. So each interior angle measures 120 degrees. All right, so there's that little question. We have this other kind of big idea here, that or key idea, that the sum of the measures of the exterior angles of a convex polygon is 360. So again, for this quadrilateral, or whatever you want to call it, some kind of quadrilateral here, we have interior angles, and then we have exterior angles, right? So that would be an exterior, that's exterior, that's exterior, and that's exterior. Okay, so the sum of these would be 360. So that is something we're going to use to answer some questions. And so we have, what do we have here? 1, 2, 3, a quadrilateral here, and they've labeled 1, 2, 3, 4 exterior angles as 50, 91, and 127. But I know plus x will equal 360. So solving this, we're going to simplify that left side. 50 plus 91 plus 127 equals 268. So 268 plus x equals 360. So x will equal 92. And for this triangle here, it's the same deal. Let's see. So 124 plus z plus 26, there's there, plus z equals 360. So collecting my z's, I'll have 2z plus 124 plus 26 equals 360. And then adding 124 and 26 will be 150. So 2z plus 150 equals 360. So subtracting 150 from both sides, 2z equals 210. So dividing both sides by 2, z will equal 105. Z equals 105. Okay, I think that might be it. And yes, that's it. Okay, so that covers all the examples from the lesson. We'll see you in class when we cover this lesson, or maybe before. I hope to see you soon. Have a great rest of your day. Bye-bye.